If you want to get 100% on your June exam, ensure that you enroll to our online courses for just 35 Rand per topic. So today I just want to answer this analytical geometry problem, and I want to show you guys the importance of having to mark your diagram when answering your questions. So this is how I expect everyone to answer the analytical geometry questions when you are writing your June exam. Now, this is your structure, right? This is the structure that you are actually being given. However, I did omit some information because I was too lazy to copy the question. But however, let's just try to answer this question and see how we're going to get far with it. Now, here are the questions. The first question says, calculate the coordinates of C, the midpoint of QR. Now, how can we find the coordinates of C? We realize that the coordinates of C, it is actually the midpoint of QR. That's what they've actually told us in the statement. How do we calculate midpoint? Well, we know that if we want to calculate midpoint of C, it is actually going to be x1 plus x2 divided by 2. And then we're going to have y1 plus y2 all over divided by 2, right? Now, let's just try to decide which one is which. Now, I'm going to say x1 is going to be 4. And now, my x2, it's going to be the 6, right? So I'm just going to add this with 6, and I'm going to divide this by 2. Now, let's try to find this one as my y1. It will be 5. So I'm just going to have 5 plus, and this is going to be my minus 5. So this is going to be minus 5 divided by 2. So we can quickly see that this is the same as this. 4 plus 6 divided by 2. We're actually going to get 5, and this is just going to give us 0, right? So it means that the coordinates of C, you need to come and say that the coordinates of C is 5 and 0. You need to put that information down because you never know what it is going to be used for onto the next question. Now, the next question says, determine the gradient of PQ, right? Determine the gradient of PQ. Which one is PQ? This is PQ, and likely we have the coordinates of PQ, right? So how do we calculate the gradient of PQ? Well, I'm just going to say, well, the M, the M of PQ is going to be y divided by x2 minus x1, right? Now, which one am I going to be which? Okay, let's let this one to be y2. It's going to be 1 minus, and let's let this one to be y1. It's going to be plus 5 because the negatives will cancel one another. So let's just divide this. So it means that the negative 6 is going to be the x2 minus, and then we're having minus 6. That's going to be the x1. So what is the gradient of PQ? So I'm going to have 1 plus 5 divided by minus 6 minus 6, and I get a gradient of 1 over 2, right? So what do? I immediately come here and say, well, the gradient of PQ is going to be minus 1 over 2, right? Now, what does the next question require us to find? They say, determine the equation of PQ, right? So we need to find the equation of PQ. Let me show you a wonderful way of determining the equation of PQ. You're going to use this wonderful equation. It says y minus y1 equals to mx minus x1, right? So it is y. Let's just use this 1 as my y1. It's going to be minus 1, and the m is the gradient. We just calculated it's a half x, and then the x is going to be minus is going to be positive 6, right? So we're going to have y minus 1 equals to minus 1 over 2x minus 3. So if we take the 1 into the other side, we're going to have minus 1 over 2x minus 3 plus 1. Guys, I just want to be safe. It's going to be minus 2. So we get that the gradient of what? Of PQ is going to be y equals to minus 1 over 2x minus 2. This minus 2 tells us that B is actually the coordinates. It is actually passing through what? minus 2, right? B is actually passing through y equals to minus 2. Now, let's go and find the next question. This is how you answer these questions. You need to be putting the information on your diagram. Now, the next question say, calculate distance PR, right? Calculate distance PR. Which one is PR? This is PR, right? How do we calculate the distance of PR? Let me just put this over here. Well, we're going to say, well, the gradient of PR, we're going to say the distance of PR is going to be the square root of x2. Is it x2? Oh, God, I've literally forgot the equation of gradient. But I think it's x2 minus x1 squared plus y2 minus y1 squared. I haven't done this in a long time, right? So if this is wrong, well, you're going to correct me. So let's just say x2, it's 4. And then it means that x1 will be plus 6. And then we'll square it plus y2 will be 5. And this one will be 1. And then we'll square it. So I want to find PR. Obviously, it will be on a sad form, right? So if I hit this on my calculator, what am I going to get? Okay, I get 2 the root of 29. So what do I do, guys? I immediately come here and say, well, the distance here, it is 2 this, right? You just come and write that information on your on your diagram. Now the next question says, show that PR equals to 2 BC, right? We need to show that PR equals to 2 BC. Okay, PR, where's BC? Oh, this is BC, right? We need to show that the PR equals to 2 BC. Now, how do we do this? We just need to find the, the distance of BC. Let's just find it. The distance of BC. How do we find it? I'm going to use the same equation, but this time it is actually for BC, right? So what's going to be my x2 is going to be 5 minus 0 squared plus, and then my y is going to be 0. All right, now let's actually plot this inside a calculator. We need to get root 29 at least. We need to get root 29. So it's going to be 5 squared plus 2 squared. Oh, yeah. So you find that BC equals to root 29. But like this actually speaks for itself. If this one is root 29, you can clearly see that this one is 2 root 29. So therefore, PR is 2 times BC. We don't need to show. This is 2 root 29. This is root 29. We don't need to stress our heads with that. Now, let's go to this question. They say we need to prove, not to show, to prove that BC is parallel to PR. They want us to prove that BC is parallel to PR. They want us to prove that BC, right, is parallel to what? To PR. Okay. Oh my God. How can we prove that BC is parallel to PR? Why? How can we prove it? We can prove it. Oh my God, this question is so nice. I didn't notice this. So to prove that BC is parallel to PR, we need to say, okay, if PR equals to 2 BC, right? Therefore, okay, if PR equals to 2 BC, right? And you can see these ones are marked, right? They told us that these two are midpoints, right? And PR, and RC equals to CQ, right? Therefore, okay, let me just say, if PR equals to 2 BC and RC equals to RQ in triangle QPR, right? Therefore, BC is parallel to PR. Why? Because this is what we call the what? The converse midpoint. This is the midpoint theorem. This is the midpoint theorem, ladies and gentlemen. It is the midpoint theorem. Look, they've just told us that this PR is 2 times BC. So if PR is 2 times BC, and at the very same time, PC equals to CQ on this triangle, that is the midpoint theorem. So in order for the midpoint theorem to happen, so it means that indeed PR, right, is parallel to PC. That is the midpoint theorem, ladies and gentlemen. It's the midpoint theorem. Now let's go to the last question. The last question says, calculate the distance of our alpha. Calculate the distance of A, right? Now, not the distance, the size of A, right? We need to calculate the size of A. Now, what do we do to calculate the size of A? Well, I want us guys to look at this triangle. Let me just mark it quickly. I want us guys to look into this triangle. I'm marking it now. I want us to look at this triangle, all right? Marvel, why do you want us to look at this triangle? Because I'm looking this incline, I see this incline, and I see this angle. Now, let's try to find theta 1. How can we find theta 1? Well, we know that to find theta 1, oh my God, I've run out of papers. Okay, I'm back. Okay, to find theta 1, how can I do it? I'm going to say, well, the tan of theta 1 is going to equals to the gradient of PQ. It's going to equal, this is, if you don't know this formula, you better enroll to our courses, because I don't have enough time to explain, you know, everything here now. Now, let's actually look at this. Now, it means that the tan of theta 1, it is going to be minus 1 over 2 because the gradient is 1 over 2. So we're going to find theta 1. So I'm going to say, well, the tan of minus 0.5, it is going to be, my calculator is on radians. Let me change this to degrees. The tan of minus 0.5, I get negative 26. So I find that the answer that I get of theta 1, it is minus 26.56 degrees. So to actually get this angle, okay, by the way, if you get a minus 26.56, it means that we have actually got this angle, if it is a minus. So if this angle is minus 26.56, it means that even this angle here is going to be what? 26.56. Now let's come and find this angle. Okay, I've actually run out of time, guys. So what you want to do is you will find this angle, right? So if you find this angle actually equals to this angle. So because you have found this angle, now on this triangle, you're going to use the sum angle of a triangle to actually find the value of A. So how do you find this angle? Just find the gradient of PQ and use this formula, right? So otherwise, guys, I'm going to see you on my next video.